these A's and B values, no matter what way you're going, this value of A is always the distance from center to vertex. The center today is always going to be at the origin. Tomorrow we'll shift them. We'll add an H and a K to it. All the process works the same. It's really not that complex. The B value would then be the distance from the center to what they call a covertex. Okay. And then lastly, the C value is going to be your center to your focus. It's very easy to remember which ones go with which. C, there's a focus, there's a C and a focus. So C goes to focus. Okay. All right. Now, what they're doing here is, in order to be able to tell whether it's squished left and right or squished up and down, it's always dependent upon the A and the B. What I want you to notice is that these are your generic equations. They're on your sheet. X squared over A squared plus Y squared over B squared is 1, or X squared over B squared is Y squared over A squared. How you're able to tell which one is which is done by which number is bigger. A squared is always bigger than B squared. A will always be bigger than B. So in your denominators and your fractions, when they have these written out, it's going to be very easy to distinguish which direction it's going. When we get a numerical example up here, I'll show you how that works. It's very simple. The other thing I want you to remember of, obviously, the C value is easy to know which way it goes because C, there's a focus in C. A is important. It's the first letter. You agree? Vertex is important. Covertex is kind of like the second person. I like the second letter. The chunk. Okay? I guess. Sure, it's the Joe Biden of math. So, B, Biden. Anyway, this value of A is always going to be from the center to a vertex. B is center to a covertex. C is your center to the focus. There is one little twist that we'll throw in here in a little bit. But what I want to do is show you a numerical example of how this flows. And it's very, very simplistic. You don't look like you believe me right now.
Me?
Right.
Well, it's the whole like simplistic word that's in there.
Well, you'll see. I have a feeling that you'll be fine. Let me show you this. Let's say I have the following equation, and I want to write the equation in standard form of an ellipse. And I have 9x squared plus 16y squared equals 144. And I want to make it look like an equation for an ellipse. Our equations of ellipses have it equaling to 1. Do you agree? So how do I turn a 144 into a 1 without subtracting 143?
Divide by 144.
Good. So all you do is you divide everything by 144. I wanted to get it the one side equal to 1. I wanted that side equal to 1. So when I do that, you wind up with some pretty easy fractions. X squared over 16 plus y squared over 9 is 1.
We can just use that method to find that.
9 over 144 is 116.
Why don't you just subtract 143?
Is that- because I want to have fractions. And if you can't do that in your head, use a calculator. 9 over 144 is 1 over 16. I don't put the 1 in there. That's all. Just simplify. Just a simplified fraction.
Will it always just flip the?
No.
Okay, so it's just depends on.
Yeah. Right. Which number is bigger, 16 or 9?
16.
Which one is playing the role of a squared then?
16.
Which way is this stretch? Left and right or up and down?
Up and down.
Left and right. So here's what you do. Once you identify which number is bigger, and you know that it's stretched left and right, draw a picture. It's going to go like that. That way you know to follow through on that. Yes, ma'am?
How do you know again, like what, which way it goes?
Because one equation goes with one.
The a squared term is always bigger. So if the bigger term is under the x, it's stretched left and right. If the bigger term is underneath the y, it's stretched up and down. Always, always, always. All right, that's how this works. So now, we know what a squared is, so here's what you do. A squared equals 16. B squared equals 9. What's a equal to then? 4. Plus or minus, ladies and gentlemen, we took the square root. Right? It's the square root of 16. All right? What's the square root of 9?
Plus minus 3.
Okay? That doesn't get us to the c value yet, and this is where the little trick comes involved. In order to figure out what your c value is, you have to do a squared minus b squared to get c squared. It's not Pythagorean, it's counterintuitive what you're wanting to do. Okay? So to figure out what c squared is, c squared will always be a squared minus the b squared. Hence, this is why that the a squared term is always the largest. So what's 16 minus 9? 7. Okay? So if c squared, sorry, I need to run out of room here, is 7, what's c?
Plus or minus square root of 7.
Good. So c will be plus or minus root 7. Now I have everything that I need to know to plot that. I know where my origin is. Today it's always at 0, 0. I know it's stretched left and right. So I start with a little grid. My center is at 0, 0. So from that point, I go left 4 and right 4 for my vertex. Or vertices, I should say, because there's 2 of them. Are we okay with that? Now I go up and down how many? 3. There's my crummy looking oval. Label what you did. I have vertex. I have 2 vertices. One at 5, 0, excuse me, not 5, 0, 4, 0, and negative 4, 0. You okay with that? The co-vertices are where? What is it? 0, 3, and good. 0 and 3. 0 and negative 3. Now for focus. The c value is the distance from that center to the focus. Do you agree? It's difficult to walk root 7, right?
Yeah.
It's difficult to mark that. But can we all agree that the square root of 7 is less than the square root of 9? But it's bigger than the square root of 4? So where-ish is it? 2.5-ish? About here and here for my foci? Now, if I wanted to label those, because I'm going to, remember the c value, I just moved it from the center that distance. Now, since this is stretched left and right, my vertices open to it, all I did was change the x coordinate. I added root 7 to 0. I subtracted root 7 from 0. So my two foci would be at root 7, 0, and negative root 7, 0. That's where they wind up at. It doesn't matter that they give you a square root that's funky. You're probably going to have funky foci. Sounds like a cool band, funky foci. Now, Elsa, do you believe me now that it's not that bad? You believe that it's not that bad?
No, it doesn't.
Yes, ma'am.
Did anyone end up doing that extra credit?
I don't know, it's due Friday.
Ah, me started.
Yeah, it's really
So
good.
I thought it was like already due.
No, it's due
It's
Friday.
due on the third.
So, let's try another one.
Wait, question. Will you have to you'll have to grasp the foci, won't you?
I did. If you look here, I kind of just, I threw a couple of dots in about where they are.
Okay.
It's 2.5-ish. What you're doing as far as labeling is concerned, shh, guys, this is the stuff that I want to make sure that you guys are writing out after you graph.
Okay.
All right? So when we take quizzes or tests or something like that, I'll have a spot for you to list out your ordered pairs for vertices, co-vertices, foci, things like that. Where's your center? All right? After you do a few of these, you're going to see that it's graph and ellipses are pretty straightforward. All right? It's pretty straightforward. Let's look at another one. Let's do this one. I have 16x squared plus 4y squared equals 16. Well, to start out with a lot of these, they mostly do work out pretty clean for your A's and B's. Don't get me wrong, there will be times you'll have some weirder ones, but for the most part, they're pretty clean. No, what you want to do is you want to set that, you want to set the equal to 1. So you want to do a 16 right now. Because what you want to do is you want to get your fractions. Okay? I'm sorry. I had to. You know me, I'm a jerk. So divide everything by 16. Everybody okay with that? So we wind up with x squared over 1 plus y squared over 4 is 1. Now, I'm leaving it as over 1 because when I'm dealing with ellipses, bless you, when I'm dealing with ellipses, everything's a fraction. It just helps to remind me what my values are. You don't have to. I think it's just a little bit easier. So looking at this right now, could you tell me what direction this is stretched? And why is it stretched up and down?
Because A is on the right.
A is on the right. 4 is bigger than 1. So I know it's crazy. So what I'm going to do is sketch that next to it.
It's because A is under Y.
Correct.
Because I'm doing the additions.
Yes, because A is under Y. Now, remember, the reason that I'm just putting that there is that the arithmetic part of this problem, once you get going on it, is relatively easy. It's just remembering what direction you need to go to make sure you don't make a dumb mistake in the end. I've seen it so many times where students will get all the math right, but they plot the vertices in the wrong spot because they didn't give themselves a heads up of what it's going to do in the end. All right? So now, what's your a squared term?
4.
So a squared is 4. So what's a?
Plus or minus 2.
B squared is?
1
So b is?
plus or minus 1.
Okay. C squared is going to be 4 minus 1, which is 3. So C is?
Plus or minus 3.
Okay. See how fast it is to go through the arithmetic part of the problem? All right. Plot it. Our centers are located at the origin, so we're going to start at 0, 0. I know that this is up and down because I told myself to remember that at the beginning of the problem. See how easy it is to forget if you don't do that? So if I know that's going to go up and down, I know my vertices have to go up and down. So I walk up 2. I walk down 2. So my vertices are located 0, 2, 0, -2. Do me a favor. I know you could probably get away with writing it as 0 plus or minus 2. Don't do that. The reason is tomorrow when we shift these, it's not going to be that clean always. Okay? Take a second, just write out both ordered pairs. It'll be more helpful tomorrow if you do it that way. Co-vertices, the B value was what? Plus and minus 1?
Yeah.
So I walk left and right 1. One, 0, -1, 0. Draw your chromie oval, because Lord knows it's going to be perfect. Yes, ma'am.
Is there going to be any point in the year when we use like actual graphs, like we have to use graph paper and everything?
I don't know. Maybe. I like doing this visual stuff. I don't think there's a necessity for graphic with this. I really don't. Okay. And then lastly, our focus. Remember, your vertex always opens to the focus, so my focus be placed up and down or left and right? Be placed up and down again. Square root of 3 is a little bit more than 1, right? So the square root of 3 is about here-ish, and the negative square root of 3 is about here-ish. So my foci will be at, what's the ordered pairs then?
0, 0, √3, 0, -3.
Perfect. Foci will be placed at 0, √3 and 0, -√3. Because you want -√3. Because your C value is the square root of 3. C squared is 3. So, just like we did with parabolas, you were able to tell that wherever your vertex was always looking at a focus. It's the same thing here. Your vertex is looking at the focus. All right? The other thing that you guys did with parabolas, if you remember, we not only graphed them from the standard, we had arranged things around or graphed in the standard form, then you also were given parts of the parabola, write the equation. Gee, guess what you're going to do here?
Get parts
Same
of the
thing. Yep, you get parts of the ellipse, you write the equation. So let's do this. Let's say we have a vertex at, we'll do the first one, 0 and 7, and a co-vertex at -6 and 0. Yes. Usually vertex goes up front. So if I'm given a vertex and a co-vertex, yes, ma'am.
Never mind.
Go ahead.
Well, it comes later, like you can explain it first and then.
What do you think I want to do first? Yes, ma'am.
Find out what direction it's going. I think it's going up and down.
Well, how would we be able to tell what direction it's going? By doing what? Mr. Allen?
The vertex, the number that's not 0, 5.
Okay. Good. And you're right, that is one way to do it. What's another way that I can see what's going on? Graph it. Graphing it real quick, just a rough idea of where you're going helps out tremendously. Just to give you an idea. That way you know for certain if you're being stretched up and down or stretched left and right by looking at your values. And you're right, since I'm going up 7 from the origin versus going left 6, I went more up than I went left. Therefore, my vertex, the distance from here to my vertex is known as A. Very good. So that's my A value. A is 7. B is, oops. What's going on here? B is 6. And you're right, the distance here is still 6, even though it's negative, it's just going that direction. Okay? You're right, distance is absolute value stuff. So if my A value is 7, B value is 6, we know it's stretched up and down. So I know my generic formula always starts as x squared plus y squared equals 1. Where does the A squared term going to go? What's 7 squared? What's B squared? And you go to the next problem. Pretty clean, isn't it?
So in a problem like that, you don't want to, you don't have to write out.
No, let's just write the equation.
Okay.
Write the equation standard form. Okay.
Sounds good.
Wait, but didn't it ask for the focus?
I'm not worried about that right now.
Okay.
I'm not going to worry about it right this second. I just want to start with this. Because the next one, I'm going to give you something with a focus and see if it works out. Yes, ma'am.
Oh, never mind. He just asked my question.
Oh, what happens if you have a focus?
Yeah.
It's very easy. I'm glad you asked. If you happen to have a focus, once again, we're centered at the origin. I have a vertex at -7 and 0, and a focus at -2 root 10 and 0. It's okay. It's okay. Have ye of little faith. All right. Yeah, that's exactly what you do. So, once again, what I'm going to do is visualize where this is going. You could probably tell right now which direction this is going. I have a vertex and a focus. Aren't they on the same line? Won't vertices and foci always be on the same line, whether it's horizontal or vertical? These guys are the same x value
So they're.
if you're laying on your side. Or, no, sorry, you're right, because they are horizontal at the same y value. Thank you. I wasn't. Ouch. So this is why I don't do things in my head, because it doesn't work. I plot. -7, 0. So I know that this is my A value is 7. I know that because it's a vertex. Vertex, the center, is always A. Now, 2 root 10 is the center to a focus. That's my C value then, correct? Since I'm centered at the origin, I know that the C value is going to be 2 root 10. Remember, C squared is A squared minus B squared. So if C is 2 root 10, what's C squared?
But
Well,
it's squared.
When I'm squaring it, does it? Because remember, I'm doing a distance, because I'm talking distance-wise. It's going to be on either side. Okay? So if I take -2 root 10, I get 40. What's 7 squared? So 40 has to equal 49 minus what? 9.
No, B is 3.
I don't care what B is. All I'm worried about was B squared. I squared this. C is -2 root 10. 2 squared is 4. Root 10 squared is 10. 4 times 10 is 40. If you throw that in parentheses and your calculator and hit the square button, you kick out 44. All right? Because I'm falling back to what I know about this. I know the relationship between the A squareds and the B squareds. A squared minus B squared gets me C squared. So I know that A squared is 49 now, and B squared is 9. You're right, B is 3, but does it make any difference for me? It doesn't, because I don't want to graph it, I just want to write the equation. I know this is stretched left and right, so does the A squared go underneath the X or go underneath the Y? Good. So it's X squared over 49 plus Y squared over 9 is 1.
How do people come up with math?
I don't know.
Very smart.
Wait, they're giving like problems that are like real world, like what does this mean?
I can show you. I'm just getting, we'll get to the real world problems of these things later.
Wait,
We're
so
just-
we're gonna have word problems on this part of the test?
Oh, yeah.
They're just not.
Okay.
So, when we have our test, it's only gonna be over the stuff we learned after our last test, right?
Maybe. Yeah. Yes, ma'am.
So you just want us to write the information?
That's all I'm doing on these. Give it that information, I just want you to write the information. Tomorrow, what's going to change is that when you're plotting your values, it's not going to be always centered on the origin. You'll have an H and a K, a horizontal and vertical shift. So when you still plot that through, as long as you're being able to identify where things occur, it's very simple. Yes, sir?
When you have a parameter, can you go up and put it in?
Yes.
Are we gonna be learning it?
You do that in Greek out. Yes. Okay. We hit trig really hard.
I'm down with that.
Go ahead and set that one up, please. I'd like you to graph and identify the important parts. What I mean by important parts here are your vertice, co-vertice, and foci. We'll take a second and do this one, and then I'll give you some problems to try out. Let's see how we go. I'm assuming you guys divide everything by 250? Yep. So you have x squared over 25 plus y squared over 10 is 1. Good. What way is it stretched then, Michael? Left and right? Left and right. Stretched left, right. So I'm going to do that. The reason that I know that it's stretched left and right is the larger value is underneath the x squared term. So now I can go ahead and start labeling out parts. A squared then is 25. A is plus or minus 5. B squared is 10. So B is plus or minus root 10. And it's okay, leave it like that. I don't want to see any decimals because decimals are for jolts. C squared is going to be 25 minus 10, which is 15. So C will be plus or minus 15. And this is okay. What I want you guys to understand that decimals, or roots, and all that stuff, they're numbers too. All we're doing is getting visual representation of what it is. I'm stretched left, right. 1, 2, 3, 4, 5. Does everybody agree that the square root of 10 is a smidge more than the square root of 9?
Yeah.
What's the square root of 9? So the square root of 10 is a smidge more?
It's like,
About here? And about here. Is that okay?
Yes.
All right. So here's what I want to do now.
Are you gonna make us label where we put them?
Here's what I'm going to do now. I'm going to label my ordered pairs. My vertices were at 5, 0, negative 5, 0. My co-vertices were at 0, root 10, 0, negative root 10.
Sorry, I forgot. I thought you were the root.
And my foci, root 15. Root 15 is a little bit less than the square root of 16, right? So it's less than 4? No.
oh, that's so close.
Square root of 15 is almost the square root of 16. Do you agree? Square root of 16 is 4. That's less than 4. So here's less than 4.
Oh, and that's what I was thinking.
So there's my foci. So it'll be at root 15, 0, negative root 15, 0. When we do the hyperbolas next week, that's when your foci is outside. Your vertices still looks at it, but it's just going in the direction. Okay? So we'll get through those as well. What I want you guys to do tonight, I've got 3 of them for you to graph, and then 6 of them to write the equations. When you go to write out your graphs, this is where you guys are asking, I expect to see this. I expect to see all those ordered pairs. I know that our center is at 0, 0, so you don't have to label that. Tomorrow you'll tell me where your center is. Very simple because it's H and K again. So let's do these. This is section 10.4. Oh, forgot what page number it was, but I'll tell you in a second. I want you to do numbers 27 through 29. Those are graphs. And then 57 through 59, 63 through 65. Those are writing the equations. You don't have to graph them, but I will suggest that you rough sketch the values they give you to help identify parts. It's so much easier to visualize the parts if you have a picture. Right? I don't remember what page. If I could get your page in your book, what page does that start on for 10.4? It's like 612. Oh, it's 613, I think, right? It's not 612. It starts 612, guys. Okay. Later this week, tomorrow we'll do the shifting of the ellipses. On Friday, we're going to do something you've already done. First of all, we'll watch people's videos and laugh at them. Then after that, we'll talk about circles. Circles should take 10 minutes because you've done that. Therefore, you'll have time to complete any assignment I give you. Deal? What? Yeah, videos on Friday.
So,